How the heck did I get the chat to stay up? What's up, man? Okay. Pause the back feed. Maybe I did that. That'll do. Welcome to Friday night. Evening. Sorry I didn't give you a heads up, by the way. Got off of work, kind of half recovered from caffeine. And gonna do all the boring cam work tonight. Where we left off, I have the exhaust ports for the most part pretty dialed in, pretty happy about that. Gonna try to finish up the cam with everything else that I got going on to try to post this out and get some code tests running on the UMC 1000 where I work, just to see if Fusion 360 is not hitting limit switches and stuff that Fusion, the machine simulation, may not let me know. Get the tool library up for that thing. Cool, got that as a reference. Yeah, me too. I've been training new guys at work and making parts and trying to keep the train on the tracks. Excited for this weekend to actually work on the things that I've been working on for a long time. Yeah, they'll let me, basically been told by people that matter that I'm an idiot for not using their machines. So, pretty, I don't know how I feel about that. But I'm trying to take advantage of it while we got it. So, Eric, what's going on? So right now I'm trying to just getting caught up of what I have done so far. We got a couple of issues to resolve. I think my key cutter, because this is all undercut way down in there, my key cutter holder is, well, the cutter itself is not long enough, so see if I can find. Yeah, so this, I have like a saw blade cutter that I'm dropping in and then very lightly pocketing out, and it's only like 1/8 of an inch thick, so I got to do a couple of layers, but I can kind of haul butt around there, and there's no place for the chips to get in and out, and you'll have a pretty good spray of coolant as that's working its way down, but a lot of those chips are going to have to push themselves back up and out, so I'm not going to cut heavy there. If you do one for the Jeep 4.0, do one for the 300 Ford. It's the right thing to do. I think I need a bigger machine than the 1000 to do the to do a 6-cylinder. Doing the Dodge Viper itself, I've got just a basic start on that. Let's see here. I ordered like a Gen 3 head gasket and a Gen 1 head gasket because they're both, excuse me, each of the generations are each quite a bit different. And I can guess my pushrod spacing kind of off the gasket, and I imagine they didn't change the blocks too much because I think some of the heads are interchangeable. But I don't know how far the tappets are down from the surface. So this is kind of the initial plan for the initial port layout for the Dodge Viper head. It's very, very similar. It's basically like a stretched out design of the LS head. But I'm very excited to start on this, but Dodge Viper blocks aren't readily found. Let's see here. You know, I don't know if there is a 4-cylinder version of that thing. It wouldn't shock me. The old car companies have done so many crazy things in the past. Different variants, especially through the gas crunch. That'd be... It's probable. It's probably easier to find a 6-cylinder head, though. But one of the issues is I can't assume with like the 300 inline 6 Ford or the whatever the 49 or whatever 51 Ford. I can kind of guess where the pushrod spacings are going to be, and that can give me room and clearance, kind of like what I've gotten with the LS, right? I can leave a pretty big passage for the push rods to come through and pick up on the rocker arms. What I don't know is if you're looking at it this way, like if it was a straight 6, if those tappets are way down here, there's an angle, right? I have to be able to reach somewhere about right here down to pick up, and I don't want to run a lot of push rod angle. And the further down it does, it helps the angle, but it also wants to interfere and hit the blocks. Like the Dodge Viper, if they're too far down, I may not be able to utilize this valve angle, or I'm going to have to compromise the exhaust rocker arm design to make it. And so I have to really analyze the block to kind of determine if this stuff is going to work or not. Should do it. If you can go buy a block and start reverse engineering stuff. Take the Fusion, get Fusion 360 and start working in it. You can I'll help you design them. I've got no idea which 2.5 they're talking about, unfortunately. Okay. Got those. Go. Duplicate that toolpath, that toolpath. Did that one twice, didn't I? this one. 5 throttle leave. 10 on the wall. 5 throttle leave. Saying 4. Did I leave 4? So one of my worries about taking these lower speed engines and putting a high RPM head on it is you need to validate if your oil pump, crankshaft, bearings, all that will tolerate it. Gotcha. Do the sheet metal block thing. Excuse me. 5. This one should also get full depth, leaving 5. Leaving 5 thou on axial, 10 radial. Same, and then the plasma cutter would cut with tight enough tolerance. I don't think a laser would cut it with tight enough tolerance. I think you can initially blank your stuff out, and then you're going to have to true it up on a mill, whether it's manual or CNC. You could get it done either way. Why is that not getting all the way down? Oh, height, of course. Top height. So the highest point would be. Doesn't really matter. There. Oh, the old 5.7 steel heads. I think some of the old big block Chevys, guys commonly ran like the L88 Reynolds blocks and the Winters blocks with steel heads because they didn't have aluminum heads back in the day for the big block. Or if they didn't want to run the Winters because they're problematic and porous. It works. I think the advent of the MLS head gaskets, the multi-layer steel, it lets the head dance around a little bit more and deals with thermal expansion, whereas I think older gaskets, whether they were graphite or whatever, they would tend to tear through that thermal expansion. But your head typically gets quite a bit warmer than the block. If your block's doing its job, you have a stainless or a cast iron sleeve. Doesn't seem to really bother them, and the heat's mainly contained, in between the cylinder wall and the water jacket. I think with the right gasket, it's totally doable. I mean, we run aluminum heads. I mean, just look at it the other way around. It's really no different. There we go. That looks right. Each of those entries are kind of stupid and time wasting. We're just going to plunge them. Okay, that should be good. That stock catch up. Welcome. Trying to do a little answer Q&A while I wait for Fusion 360 to calculate its stock, and my goal here is to, if you didn't catch the front side, I'm trying to get a legitimate program done so that I can go and run graphics on a Haas UMC 1000 that I have access to. Almost lost that computer. Hate logging in. But I want a whole program that I can go load into that mill, load the program, set up the tool offset table, and make sure I don't hit limit switches. I don't know if Fusion 360's machine simulator catches all the limit switches and all the other stuff that can bite you out on the shop floor. It'll kind of validate if a UMC 1000 is the right machine to get, or if there's concessions I can make on programming that, okay, I can't run the Z all the way down or run a longer tool to keep all within parameters of the machine, or do I have to find a UMC 1250 or get a larger machine to do it? The other way around it is I can go and kind of finish them off at my shop on the trending table that I'm building. Hopefully not. I kind of want this to just go in, do a first operation, get bolted on the fixture, do the second operation, and be ready for quick deburr, a wash, and final machine work. Okay, that'll lead into it nicely. Let this one generate. Actually, let's start attacking all these little water ports. So with Fusion, you have this little drop down. You can do all kinds of different stuff like render, animation, or simulation. And I'd like to learn how to play with this to do a little bit of the finite element analysis. All I really use is design for drawing and then manufacturing. So making toolpath for CNC machines. Let's see here. So when you have like deep slots like this, like that's fairly deep. Some of these go deeper than not. That's about an inch. Going in with an end mill, you just can't plunge end mills into stuff with a lot of success. And so pre-drilling these things, it makes your cutter's life a lot easier. And then these are all designed around either a 1/4 inch end mill, just kind of doing a zigzag all the way down, or if you can take it like a 6mm cutter that's just a little bit under and do a ramping, you can kind of blow through these as well. So regardless of what you're doing, having a pre-drilled deal is quite a bit nicer. So we'll use the project tool, generate sketch center lines here. So I don't need to tell Fusion 360 that there's a complete circle or hole. I just need the center point of where that drill is going to go. So these arcs will give me a center point. This one, see if these don't intersect. That one probably, well, we'll have it. Turn profiles off because I'm not doing anything. Oh, that kicked me out? Yep, it did. So we got our sketch. We'll go back to save. Oh, exit out of sketch first, I guess. Hit save. Back to manufacture. There we go. Okay, guess I'll recalc these. So this is definitely the work that no one else wants to do, typically. This is the glorious life of a CNC programmer. Because you set up what you want, calculate your tool paths, make sure everything is correct, and then you kind of sit around and wait. And then you go back to panicking because you're eager to get the next tool path going once it goes, or once it allows you to. I could work ahead in this. Fusion is pretty good about letting you run ahead of the stock generation, but I try to watch what's coming up and what see if I made any mistakes along the way. So when I go back and review all of this tool path, right, just a couple of things to review. I will go through and review every single one of these jobs, make sure I'm not crashing the machine, breaking cutters, ruining my part. I'll go through every single one of these and make sure that the code is safe to run. That you make that part of the job, which is probably the most lame part, as easy as possible. Yes, OBS is much easier. At least for the streaming part, not for editing videos. Or I'm too stupid to know how to use it to edit videos. So right now my projects are all on hold. Spread kidney cancer. That's no fun. Good, don't quit, bro. That's intense. Holy crap. That's crazy. Thanks for being here and joining me on a Friday night. Hope you're taking care of yourself, dude. Wow. Okay, that looks about what I want. So we will go to drilling. Have to make a tool for this. Let's say 1/4 inch drill. Caps only. That's the way I roll. Drill. Good steel. Yeah, I guess that'll be about right. Overall length. Not going to use that large of a drill. Length below holder. Oh, I do have to go deep. Okay, let's make that like 2 inches. Shut up. Flute length. So if we live dangerously here, maybe go. This would be about 4 inches long. Length below holder. 3, 2.5. Should be something in there that looks about like that. 236. How's my clearance? My clearance is pretty good. What's that look like? Nope. Drill trucks are for fools. Let's see. I know none of those are going to reach. So you need like an ER call it. Sorry again. So Fusion, I see how it's red up here. It runs off the cloud, but you can work kind of through periods where you work offline. So if you don't have any internet access, you can do that. I tend to do that because it seems to. It may not be faster, but it's more consistent when it's not contacting home all the time. There we go. PR16. That looks about right. Let's see. Flange feed rate. Bus processor. I always forget this. Tool 55 for right now. We got 29. That'll be tool 30. So built the tool. Get tool orientation. Leave that for Z-axis. X-axis will be that way. So now I got to select points. Did that select the point where I wanted it? Yeah. Nope, those are interfering. Just got to do one there. Oh, made a mistake. So I've selected all these points, but I have different depths for each of these drills. Let's see here. Yes, that's correct. It's definitely, it seems to be more CPU intensive. You know, I have this Fusion 360 assigned to the 3060 alone, and so it's got no issue, you know, rendering very basic like shapes. I think most of my GPU processing right now is probably from the stream more so than Fusion 360. But this thing will come up, you know, sometimes calculating toolpath, you'll see this have a big old blue wave of calculation on the CPU. Not that this is the hottest processor in the world, but either it will thermal manage itself down to like 30 or 40%, but a lot of times it seems like it's Fusion kind of not being able to process or take advantage of stuff as well. Oof. Okay, and that's a different depth. Is that right? Nope. So I think all of those are at the same height. Full top, we'll do selection. Okay. So it'll look correct. Full top. Just to be safe, go from there. Feed height there, top of stock, great. That should be fine. Full retract. So like 50 thou. Yeah. This thing does pretty good. It's like a MSI Pulse. Hopefully this doesn't screw it up. Pulse GL66. It's a couple years old now, but I've found that if you get enough computer, the software just sometimes takes a certain amount of time to calculate what's going on. this one, put drill tip through bottom. Same profile, same profiles. Yeah, I've been pretty impressed with the MSI laptop. It does pretty well. I have no idea what Cache is. OS, I'm guessing is operating system with Hyperland, and I have no idea what that is. Mr. Eric, there's obviously someone watching out for you despite your terrible luck. You're still here with us, and glad you're here with us right now. Okay. These are going to be deeper. So, got that face. I'm going to pop through to there. So 1.9. Duplicate. Edit. Punch through to at least there. Drill tip through bottom. Right another 30 thou there, just for good luck. Let's see. Okay. Put those weird holes in. Go about the same with that. You could also hit that with a bigger drill. What radius is that? Okay. We'll make a neat tool for that. So duplicate. It'll be the same. Do. That'll work. Tool one. Okay. Hides. See if I can gang all these together. That's about right. Take that out of it. Okay, that looks pretty good. No, I don't deburr my parts. I only program slowly like this too. There's no other way to do this right. Well, I don't deburr them in the machine. Damn right it does. You guess? You want to call and be on speakerphone? Should I use a form tap or a cut tap on this, Dakota? If you're at the bar with your parents, I definitely couldn't let you on. You would say bad words. Okay, for drilling those, we'll go finish that. I mean, I might go cut tap. I could. I don't want to. Nope, can't say that either. Trying to find an acronym for KMS, like Kiss Mom or something, but it's not. It's not working out. No, we're making cylinder heads, not funnels, you idiot. Sorry, I got a friend in chat. Possibly even a coworker. Okay, 1/4 inch there. I gotta make a spot face. Let's see, tool library. See if that's long enough. Have fun at the bar. That's a drill. That won't work. Okay, let's go pocket. I'm gonna have to trick this thing a little bit because I programmed it right on nominal. Oh, that's a ball and mill. I don't want to use that one. Okay, so what is our quarter? Okay, it's just straight 30 thou. Flute length is 3/4 of an inch. We'll play it safe here. 1.1, length below holder, 1.1. Over length, it's probably like a 3. Doesn't matter. Okay, holder. Oh boy. Pick a random one for right now. I think that's the longer one. Hydro, we're not doing much. That'll be good enough. Didn't finish doing that. Okay, got the holder, cutting data. Go. That's a tick fast. Sure. 2 degrees. Plunge, not going to use that. Ramp. 30 inches a minute. No, 40 should be fine. That's not terrible. That is 9. Yes, if you get your kids into cars, they will have no money. Geometry. Different depth. That one's a different depth. This was same and same. Is that the ones I picked? Nope. Wrong there. I really need to go all the way. Just go to there. Leave stock to leave. Cut without big. That should propagate. That needs to be 0. Maximum stuff over. We go like 30. Doesn't matter. Ramp 2 degrees. Try 3. Okay, and that's a minute and a half for that. Deal with that. Duplicate. Is that one the same depth? No, it is not. So then those 3. I think I am stuck. Nope, that one's got it easy. Boom. Blow through by 50 thou. Great. Same. $9.50. This. Let's go and trick that. So we'll go 950, half of that's 425. Okay. You can fix the XJ with a Chevrolet. Nice key cars. They are sought over here. No essence. What do you think is going to be the best combo bore and stroke for these heads? Everyone seems to think de-stroking them is going to be the hot ticket, but de-stroking works because of cylinder head saturation and lack of flow, because we'll have no restriction on flow. Diesel? Alright, that's good. I can get done with that. Oh, did not select the right pocket for that one. Big as you can go. Okay. They're for the 5.3 bore. They'll fit, like my minimum combustion chamber radius is basically 3.8. So it's made to work on the 3.78 bore. So you can have a very small bore and a very big stroke and make this work really well. I can just recut. I'll have a combustion chamber profile that'll not leave such a squish band around the combustion chamber for the bigger bores and probably a bigger valve variant. I don't know if I'll be with the one. I might not be the one to do that. Other shops that are interested in do cylinder head modification to all kinds of different heads already, I might pawn that off on them if they're willing to do that voluntarily. So I think there's some advantage to that, but also having the squish band, that's not going to hurt anything. Kind of until you head towards boosted land. Also having a softer chamber might help with that nation, depending on what you're doing. Rubicon TKs. Mr. Eric, if you are in anywhere near California, Turner's wrecking yard in Fresno is like one of the biggest wrecking yards. They're very fair. If anyone would have one, they would. That ain't right. What the heck is this thing doing? It switched the drill. Yep, it switched the drill on me. Pennsylvania. Just you got some good sprint car racing back there. 30. Nothing longer there. Let's see. Those look right. That looks correct. Trunk is there. That looks right. It's about halfway. And then this one we're going to cheat a little bit more room on the wall. I mean, like the 3D printed, like I guess that's the centered laser stuff, right? I do know they work. I'd be worried about. I'd always be worried about cracking them. I think you can make them work. I don't know if anyone can afford them. They're very expensive. Those prints are. I think you can cast. You can probably have someone go cast you a header or like an exhaust manifold for cheaper than what they charge for that. Why is that one just popping through? Okay, that's right. Boom, 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 boom. Cool. Duplicate. That pocket and that pocket. Do the same thing here. Boom. Rotary swap die 8 came out the same. Some of the rotary stuff, people get crazy on charging for that stuff. And I'd love to have Richard Holdner and Eric Weingartner and some of these other dudes get their hands on them and see what these things test out at. There's so many different ways to test these things. One of my thoughts was to take it like bow and stock 5.3, do the head swap, keep the cam dead stock, and with like exhaust manifolds in my intake, and see what the power differential was. Then to go do a cam swap. I think it'd be funny to see the difference. Optimistically, like one could hope for like 500 horsepower. So like a factory 5.3 makes 300 or 310 horsepower. It'd be neat to see that with the stock cam hit 500, but I don't think that these would do it. And then if they did somehow have enough cam for that, because that's more of a valve timing event and power band deal, you'd have to rev the thing so hard that you'd have to put an oil pump and everything else. You're heading towards a built engine already. And these by no means are stock replacement. So it'd be interesting to see a comparison from like LS3 heads, or some ported stock heads, or your common aftermarket ones, to see what happens. Typically 2-valve heads have about a 2,000 RPM peak torque to peak horsepower power band. 4-valve heads tend to have about up to a 4,000 RPM power band. So that makes a big difference. That's a lot of area under the curve. Be interesting to see. Okay, making up stock. Guess I can hit that pocket with the long one. Duplicate. Guess that don't matter. Yeah, my goal with these is hopefully if you do run them NA and you get little bit longer of a runner on the thing to where you can utilize something from 3,500 to like 7,500 RPM. That I'd like the engine to feel something between the lines of something turbocharged with no lag, and or the good old electric car acceleration to where it just pulls your head off the whole time. And it should. That's what most of these 4-valve engines do. Finally. Okay, how long does that take? 4 minutes? That's not so bad. Alright, that's better than I thought it was going to be. That's reasonably safe. Okay, how deep is this one? 950. Inch 25. Let's see. Copy that one because that's the long one. This is the 29. I'll duplicate that one as well. There. Okay. Go down 3/4. 700 down. Down. That won't rub the shank of the cutter. Should be happy. Okay. And these. Take that out of it. That face, bottom, let's see if this changes at all. 1815. Nope, same. This one will start just a little above. Want to try out variable rudder, ITB. I think they can be 3D printed from almost any engine. I'm trying an SLM to automatically go right to the right runner. What do you mean by SLM? I have no idea. Like an Arduino or something to drive it? I've always thought you could take like an Arduino or Raspberry Pi. I don't think you need that much computation. It might work super well. It still requires a a ton of dyno pulls, or I guess you could apply it while you're driving, but you need some kind of feedback for your loop. Have you seen the, I think it's Engineering Explains, Ferrari F12, LaFerrari, variable stack data? Because he kind of lays it out, and it's pretty interesting. They're moving around more than you'd think. But it's also kind of simple. It's worth looking up. Oh, I don't need. Don't need a helix there. I'll go back to plunge. Plunge. Nope, that's not going to work. Yeah, he shows the runner length. They start out long, and it gets to like 5,000 or 6,000, I think, and they shorten them up, kind of peak torque, and then they go long again, and then higher RPM, the logical thing of shortening them up, they shorten back up again. It's pretty interesting. And I think the Corvette Z06 flat plane crank engine, they're playing with that manifold baffling to kind of achieve the same result. Yeah. I mean, great way to go out and get a ticket. Go out speeding. It's where dyno time's not a terrible idea on that stuff. Minimum ramp diameter. Let's see here. I don't need it to helix in. But I don't need the lead ends here. Nope, I'm going to switch from pocket to contour. That's what I need to do. No. Let's see what that does. Let's see. drills, first pockets, second pockets. Okay, that needs to go to, oh. Yeah, I think doing a PID deal should be pretty easy to tune. I have no idea how to do it, but I think most of your motion control and kind of your self-hunting programs is going to use PID, and probably rip a lot of that information from the internet and get a lot of basically free help. Delete all those. Start over there. Cool. Contour. Have you seen the dorm room mechanic by any chance? I think he graduated to a shop, but I think he also got kicked out and was building it in the back of his hatchback or minivan or something. Tool axis. There. On that side. Set up your x-axis. Not that it won't figure that out. Geometry. That one. That one. Arrows inside. Cool. Face. Boom. Don't really care about much of this. Multiple passes, multiple depths. Stock to leave. Just to be safe there. Cool. Ramp. Don't really need lead in, lead out, but I do need a ramp. Doing 3 degrees. Maximum ramp, step down. Cool. See if that gets me. Okay, that's what I'm looking for. Gotcha, that's cool. Izu, what's FOC? I'd love to see a bunch of different open source, ECU, electronic engine controllers come out that maybe are a little bit better than the Arduino ECU. I don't like all the trends with the AI rotting people's brains out, but one of the advantages of these things is if you don't know how to program, and it can poop out code that could possibly work or is tunable, I see that as a huge advantage for getting PCBs made or getting an Arduino or Raspberry Pi to produce like a decent engine control unit, or at least something to modify for racing or different engine control stuff. You don't see a lot of that being done. It's kind of held tight. Long. Boom, boom. Tool axis. Okay, this we're gonna go negative point. Nope, 6.5. This one. Now we'll go down to that point. Don't need the offset there. 0.65, so I'll start lower. Top height. That makes me a little nervous. We're going to put that back at the top. Okay. Passes back to 1 thou. 3 degrees. That one gets a 1 degree ramp. Field-oriented control. It's very fast, high torque stepper motor. Okay. I've heard of the Russ or Roos EFI. I don't know much about it though. I heard people are playing with it. I mean, practicing on making goofy systems can't hurt, right? Okay, that's not doing anything dangerous. Nor is that. Cool. Okay, so where am I at? Okay, I need to hit those two. Boom. Duplicate. Duplicate. Switch that down to there. Should all be the same. see. Did I get the depth correct here? Probably not. Cool. Boom. Right on with the home lab. That's the way to go. I understand this having more than 10 projects thing. It's a real struggle. Okay. Let me go hide my sketch here because it's obnoxious to look at. I don't think I need my boundary sketch anymore either. Oh, that looks bad, cut part rendering. Let's give that a minute. That looks rough. Save button, just in case. Little bit better. Okay, what diameter did I make these? 750. Perfect. Oh, go. Contour. Roughing tool. Tool axis. There. There. That's supposed to be the same height. I think you can always learn something in college. It's kind of what you do with it. But they certainly don't seem to be focused on getting people to have a good application with a lot of the they seem to ram jam people through and not let people get not let them find what they can be very good at. Yeah. That's true. The when you start working on yourself and picking harder projects and stuff, the acceleration of how fast things pick up and how much you learn it's ridiculous. What have I done here? Why did it explode all my stuff? I didn't click any buttons to do this. Oh no. So irritating sometimes. Yeah, I think they can give you a good foundation. I think it's kind of turned into just like initial, like barely get a job training stuff, and then they kind of ram jam you through. There's no boredom time. There's no time for you to like innovate on your own because you're too busy about worrying about the next class or the next midterm or whatever. I was on a schooling route and I kind of bailed out of it. There wasn't much for machining, and I wanted to make billet heads and engine components, and they don't have a class for that. So figured I'd go learn machining in the School of Hard Knocks, and I learned before you had all the support on YouTube to learn Fusion 360 and these different like online academies to learn machining. I think a lot of them are actually pretty fantastic. They'll at least get your foot in the door. Not that you deal with weird software glitches of all your tools and jobs expanding. I don't know if I clicked something that like did that. I mean, I could have, but they may not teach you how to deal with quirky software, but they'll teach you how to use it and see if that's actually what you want to do for a living. Okay. I think those can go away. Don't need them. Did that do what I wanted? It's not bad. That might be a tick fast, but that should do it. Okay. We'll attack the kidney bean angled things here next. These are in here so that this drill through can have a good amount of flow through. The way this will kind of flow through this thing is That can intersect with that pocket, drop down. Water's also coming up here, so this gives it a number of different ways to go. But through each of those means, they're all interconnected. And that lets that water run up, intersect this pocket through there. Try to get two birds with one stone, and then that all returns the water up to there. I'm still heavily contemplating putting another hole. I can orient this way and come in, or this way and come in and intersect that pocket. I might add that into the model. Just give it another chance to get back. But this angled pocket here, the reason why I didn't do that as a drilled hole is these drilled holes are kind of tough. You just can't take a drill and start it on an angle. You actually have to leave a flat or punch that with a spot facing tool to do it. That's a long day. You have a good night, Eric. Okay. How deep do we have to go here? Thanks. Boom. Can't use that one. Can probably steal. Try to steal a short one here. Duplicate. Grab the bottom. Tool orientation. No, I do want that. I don't want that face. I want that face. So how's this thing going to orient that? It's going to be like that on the machine. Okay, it's alright. Good clearance on everything. X-axis will be kind of like that edge. Bottom will be that face, no offset. Selection from this face, does that give me an option? No. Okay. Let's see here. Shouldn't need to be actually all that much. Let's see, 1.5. Does it really give me a good idea? I'll try that. Will the tool clear? No, that's going to crash. Be conservative with the ramp. Don't need that offset. Let's see what that gets us. Yeah, join him in that Discord. That'd be cool. That's way too tall. I need to chop that down quite a bit. Let's see, how long is that? That's what I should have been measuring. 0.2. Expect. We'll go 300 thou. Okay, do the other side. Yeah, it'd be cool to get everyone in there. I'm guessing I can live stream in that, or if we would just want to go talk about stuff or express other ideas. Because I don't mind helping and playing with these ideas. It's great fun to me. Oh, that's not where you need the toolpath. Probably should hit your heights, John. Base. Okay. Also. That one might need a little more. I'm guessing that's what other people do, right? Like, if they're streaming, they'll also be live on Discord, and or if they're like multi-streaming, that's where you get a lot of the source for the questions and deeper stuff. I'm guessing that's how it works, anyways. Again, this stuff I'm clueless. I'm pretty darn good on CAD and CAM. I'm no IT guy, and I'm no gamer. I'm clueless. You can always come in and practice. Can't hurt. What do you mean we're antisocial? My buddy's at the bar with his parents. We got friends that are at parties right now, and it's 11:50 at night, and I'm programming a project that I've sunken too much time into, and we're all here looking at nerd stuff as opposed to going out and partying. I don't know what you're talking about. Okay, that looks good. That's a 1/4 inch. That's where, admittedly, like, if you're into engine design and doing car stuff, I find it's always kind of hard to find car friends. I'm in the central coast of California, and our smog laws really kind of impede a lot of automotive fun. And I got a decent little group of people, but the no one's really in it this deep, and I think that's kind of the beauty of the internet, is we can kind of find each other, be able to communicate, share ideas, and I think that's all pretty cool. Yeah, but what's bad is we're actually in like a subgenre. Like, if you're watching this, you're in a subgenre of limited car culture. Like, you're out in the weeds. Um, it is the reality of the situation. But I've seen the response, between Eric Weingartner and Richard Holdner and Steve Morris and all these automotive YouTubers, and it always seems like there's a deficit of not necessarily detail, but like the actual hard work. That's why my friends and I can't get along with the comments. the like the bigger projects, like like Wesley Kagan doing most of his stuff. He's one guy that made a free valve engine that worked, and that's pretty wild. He put it out on the internet, open sourced his files, and I haven't seen one person get an engine running with that yet. 8 billion people on the planet. Everyone thinks it's the next thing, the next best thing to like sliced bread or whatever, and no one can actually 3D print the stuff out or machine shop it. But you see a lot of people on YouTube doing stuff, and I think it is very hard to get people on a unified front to go in one direction with the project. But we can start on that by at least hanging out. And I mean, you guys are allowed to make fun of me while I'm programming, because I've been going since 10. I took about a 2-hour break today, and I'm not at my prime programming right now, for sure. Could almost be considered dangerous. See, that won't hurt if I make that counter bore a little bit bigger. Let's try that. Flip axes. Now we're facing the correct direction. That's in the mill. It's going to be pointed up like that. X-axis is going to be running along more like that. Perfect. Yes, people who touch grass, play in the mud, stare at the sun, all of those people are very rare now. Have you looked it up, Wesley Kagan's deal? I'd recommend doing so. That was not a small amount of work that that gentleman did. It's simple in theory. It is not simple in execution. The there's a thing with doing the solenoids too, depending on your opening and shutting speed. If they're too quick, or if you can't control them per degree of crankshaft rotation, besides if you have a non-interference engine, the acceleration of the intake valve and how that profile goes is why one camshaft, well, if you selected two different cam manufacturers with the same timing events, are very close, like 1 degree, same lift, same lobe separation angle, and you dyno them back to back, one cam will always produce more power than the other, even though the numbers are almost identical. Even with a set of calipers or measuring equipment, you could barely tell the difference. And the acceleration rates on the valve, that's kind of what determines the airflow, and that's where cams operate in different RPM bands, besides overlap sequences and other factors. There's always a camshaft that tends to work better with the air. One of the projects I have, these are actually a couple of lobes I've cut out that I reverse engineered one of our favorite flat tappet cams, that with about 2/3 to a half of the valve spring pressure will just about keep up with some of our roller cam profiles for dirt track racing and other stuff. And kind of wanted to have that in roller cam version because it doesn't hurt valve springs. You can build a pretty lively engine. It's not going to get good fuel economy, but they sound amazing. They rev. They tend to pull through the RPM band very willingly, and great for accelerating vehicles. We never really knew why, and so I built a tool on Fusion 360, 3D scanned the cam, copied those profiles, and built a tool to basically get, I guess, the involute. But as the flat tappet would roll up, I would move it every 2 degrees and have the flat tappet be tangent to the 3D profile of the flat tappet cam, and then tied that to a roller lifter, and every 2 degrees I let that move and drew a sketch to where I got the roller profile for it, and then machined it out. And hopefully next week I will get a chance from work to leave for more than 30 minutes and mail this off to my cam guy. And this is the profiles it made from a flat tappet, which is a very egg shape with a point camshaft low profile. It's kind of a very mild cam profile compared to your typical, this is a pretty high energy, this will be going into my sprint car. That cam profile's got a lot less radius, a lot more flat or inverted radius on the ramps, and that determines how an engine runs drastically. And there's some details in this that kind of make this camshaft in particular work better. And if the free valve system allowed for that tunability, that's actually where you're going to get most of your gains. Camshafts are pretty damn efficient, and all the other subsystems that you have to use for getting the free valve to work, it might take a hell of a lot more power to run those systems than just turning the camshaft, which is on pretty efficient bearings, right? You don't hardly ever see cam bearing wear or journals turning blue as long as you have oil flow. You measure a bearing's efficiency not by how it spins freely, but while it's under load, and plain bearings are radically efficient. And then roller camshafts are also pretty efficient. So Otherwise, you'd see heat build up and we'd have a lot more failure. So I think if you can reverse engineer camshafts that work or have special properties to them, like this one, what this actually does is it gets the valve off the seat, takes up the lash, and it's got a little bit of an inverted radius, and that's probably impossible to see on here, but that lobe comes up and it actually dips down a little bit and then comes up again. And what that does is it lets the lifter rise and then slow the acceleration down, and then really accelerates it when it gets back to the big bump. And what that does at the valve is it opens the valve and gets air flowing all the right direction. It kind of organizes all the airflow and the pressure signal in the port. And then as your piston just kind of, still coming up and coming down, that valve accelerates at a certain, at just kind of by trial and error rate. As when it opens, that port's got all the air prepped to enter the cylinder much more efficiently. So it breaks the air and fuel mixture down better when it does that. And then when that piston comes down and comes back up, that inertia of the air continues to fill the cylinder even though the piston's coming back up as that intake valve is shutting. There's a lot of dynamics with cams that if you look into their actual timing sequences, it almost doesn't seem like they should work at all. But it would be cool if you can get the free valve system to be that responsive. You could pioneer a lot of those acceleration rates into those profiles. I want to design my own programming power supply, controlling the transistor gauge precisely with a real-time microcontroller. It's already like a brick wall to me, let alone controlling engine valves. The cool thing with I think making an ECU or any kind of engine control device that's going to keep up with the engine in real time is your clock time on pretty basic electronics is very quick, and it's not like it's supposed to do anything unpredictably. It's a cycling engine, so if you did have some self-learned stuff in there, I think that could be a pretty good advantage. Looking at throttle position, manifold pressure, oxygen sensor, and the exhaust, if those things update in pretty real time, I think there's, some pretty cool efficiencies with that. But I think there's a lot of other ways that you can also achieve it. I know the free valve is more of like a laptop pioneer to like angle to tune an engine. But it could be a way to find little efficiencies here and there. There's all kinds of weird stuff that's still left on the table. And the whole brick wall big project thing, I didn't know if I was going to be capable of doing this when I set off when I was a teenager. Like, I had no means of learning this stuff. I had no means of doing it other than going out on my dad's drill mill and drill press and take a big old block of metal. Like, where do you find those, right? You got to go buy them and then carve this stuff out. So designing a lot of this stuff is, pushed me to learn CAD, and then therefore CAM pushed me into the machining trade. That's done me fairly well. And, you start heading towards an impossible goal. And as you make progress, it becomes less and less impossible. I can only encourage you to follow those passions. You don't have to accomplish everything in a day either. It's more about the journey. Do you know any software that can simulate the dynamics of an engine accurately? Yeah, actually Fusion 360 or most of your like SolidWorks, Onshape, if you go and model everything, you can actually have an engine that you can grab the crankshaft and move around, have all your rods and pistons move. But it's not going to describe as the fluid dynamics to the airflow coming in and out. I think there's CFD stuff that's coming out, the computational fluid dynamics, that's getting better, but I don't know if there's anything out there that's not like NASA level crazy. Or the other issue with softwares like that is there's so much tunability in the software to get it to work right that you don't know if you're having a good basis in physics and reality versus what you're tuning a software algorithm to get you what you want to see. Because you can trick anything into getting what you want to see, but does it work in reality? Yeah, I know that would make life a lot easier if we had that. But that's a direction that I'd like to head as well, is kind of do, my only way to go about it is do some myth busting on stuff. And run on prior data. That's where I appreciate some of these other engine YouTubers that are willing to do, even like on the Cletus McFarland channel, they will do some pretty dumb things. Hilarious. I thoroughly enjoy the content. They'll do really dumb things, but you kind of learn from it. And, him running 40 feet or 200 feet of intake pipe in between a turbocharger and the throttle body, turns out that's a huge restriction. But the engine, at least from my guess of how it would perform, it operated much different than I thought it would. And it was actually quite a bit more destructive than I thought it was going to be. So there's always experiments to run, and that's where I don't know if we're going to have computers completely solve that for us, but a relationship in between computation in different ways and then basic test beds of flow bench, dynamometer, high frequency sensors to maybe measure intake pulsing pressure, or having several pressure taps in an intake port and time that to the crankshaft position, and then load an engine on the dyno and see what resonance happens there. Yeah, I know how to use Autodesk. Watching what happens there and see if there's a repeating pattern in that data. That you can learn. I think the funniest part of that was he did it with a $100,000 billet engine. I don't know if I would do that. I'd do it with these heads, but I can always go out and make more. The whole rest of the engine is quite a bit more. Alright, let's see if this will let me pick this crooked contour. Alright, cool. One less sketch I have to draw. Okay, heights. Eliminate that. Select. Does that give me a good profile on the height? No. Give her a cam system. Okay, that seems acceptable. Get out of here. Can't see. Thank you. That's going to pop in there. So I really only need that to go. Bed line. Oh, let me pick that. No. See what that gets us. Okay, that'll clear. Yeah, it was all PVC pipe. Oops. It was done as about as worst as you could do it. Okay. Yeah, I think people take things a little too seriously sometimes, and I mean, God forbid he started with exhaust whistles. Like, obviously, he's trying to be obnoxious and attention getting, and he's masterful at it. But I mean, through some of these hard times these past couple of years, I don't know where my life would be without every other day getting something to be blown away by how stupid he could be or how brilliant he could be, at least on the video production side. And the world, I think, is a pretty much a better place with his content. The guy was in law school before that, and he decided to drop out to become a professional redneck. And I don't know if that's stupidity or not, but that took that's a big step to do, and I think you kind of got to respect that. And then obviously he's a pilot and everything else. He's no dummy. But just because you're smart doesn't mean you can't laugh. Did that duplicate it? Did that duplicate it? Yes. Drag that one down to there. Carter, have a good night, man. Thanks for joining. I'm about done too. It's 12:14 where I'm at. About cooked. But I'm going to try to get this water in the deck done. And that's pretty simple compared to looking at all this finish work. So you have a good night, man, and I'll try to hit you up if I get a better time, maybe tomorrow or Sunday. Other side of the world. That's amazing. It's super cool. Sounds good. I'll see what I can do. I got a stacked weekend myself, and then sprint car races at Santa Maria Speedway Saturday night. So I will definitely not be going live next Saturday, but possibly that Sunday. I'll try to be better about letting you know. I'm just yeah. I'll try not to boomer dox myself and see if Discord or OBS doesn't go. Are you sure this is you while you're streaming? That was brilliant. Or I could just change it again. You know, whatever. Hey Zoo, in your part of the world, are people putting K series and all kinds of crazy engines in the key cars like they are over here? It seems like in America we can't leave these things alone. Okay. We got two more sets of holes. I got that one to do. And we got those to do. Ooh, I can't get there from there. At least I don't think. No way. Gotta go to the next operation. Okay, let's do these. Duplicate. Oh, one you see. I love that all over the world people are hot rodding cars and swapping stuff in and out. You can drink. I believe you can always drink what they're selling, or you can make your own home brew. And the engine swap stuff, I'm always a fan of. Even if it's out of just straight defiance, I appreciate it. So it doesn't do that high. We can get a little bit closer. Alright, that works. Fuel stock, let's see, a little bit more than that. I see a lot of guys porting a lot of like the little motorbike stuff, the one-cylinder stuff, all over. Seems like in the Philippines and Vietnam and all over Asia, guys are really into hopping those things up. It's pretty cool. They're all doing a pretty good job too. There's 5.2 trillion cubic miles. Gotcha, Indonesia. Nice. 5.2 cubic miles, or 5.2 trillion cubic miles of atmosphere on this planet, and they don't want people to have fun, I guess. Not that I'm for polluting. I'm not. But I think people can be realistic on if one or two people do modifications, it shouldn't be the end of the world. It shouldn't put you in jail or fine you at least. One of my friend's fathers has got a place somewhere in Indonesia, and he's really into surfing. He showed me some pictures there. Actually looks pretty cool. Confiscate it. Yeah. It's because their police cars aren't as fast as they need to be. They're jealous. Okay. Let's see if this thing will let us simulate. Oh no. Let's not get expand the jobs disease. Please don't. Okay. Simulate with machine. See what we get. Why is it doing that? Oh well. Yeah. Very true. Okay. Let's see, wall paint. Go by operation. Move that down. Turn that off. Make that transparent. Was it to help them with their with their job or something. I know in the States I think people have fought back and not wanted like robots to help ticket and police things. Will do. Stop the shaft. Oh my gosh. Rapid moving to stop. Okay, well. Let's see what that's about. Finishing passes on the intake seats. Drilling holes. Well, I'm no engineer, just high school graduate. I was lucky to grow up under a car, and my dad's been building engines and all his life basically, and several championship winning engines, and a lot of this stuff you just kind of find what inspires you and just don't give up on chasing it. And that's kind of how I've gotten to where I've gotten. Got years and years and years into working with this stuff, and the machine simulation like this, it always makes me look a lot smarter than I really am. I know how to, do most of the stuff, whether you do it by hand, with traditional G-code stuff, line by line, or, these CAM systems obviously make life much easier, because it writes that all out for you. But the it's a crossing point between skill and imagination. Well, thank you. I I always tease. I don't know if it's the same way now, but I used to tease different people that went to engineering school and you know put in that effort, and God bless them for it. I wish I did. I just wish I would have went for like electronics or something, to better integrate software with hardware stuff. Okay, I'm touching there. Okay, we'll have to fix that. But I'm a very literal person, and I looked up the definition of what an engineer is, and the definition, at least, was probably 10 years ago, but it was someone who uses math, science, technology, innovation, etc. to better human life. The second definition in like the Merriam-Webster's dictionary was someone who drives a train, and then the third one was someone who works in an occupation where a degree is required, such as civil engineering for building a bridge. And so if you ever got kind of arrogant or cocky engineers making fun of you or whatever, I would let them know that, and they really didn't tend to care for that. But upon that definition, if you use your own imagination and ingenuity and use the tools around you to better human life, then technically, anyone like that is an engineer. So I do know that most of our inventions that make our modern world, they weren't done by people with college degrees, or people that had a vision and worked hard at it. Those were last issues there. Nope, got a couple more dumb ones. Okay, I'm not so worried about that one. Or that one. A lot of this stuff is 2 steps forward, 1 step back. Like, I got a decent amount of programming done tonight, but there's errors, and there's other errors all throughout this that I have to go and adjust. Like this, I'm starting at just a tick too low on the beginning of that tool path, and I have about 50 thousandths of an inch above the final deck surface, and I didn't select high enough for that tool to enter without collision. And this I might change by just getting this hole started and not going all the way deep with it, and then sending a drill through there. That might be the smarter way to do this. That's got a probability to screw up and break the tool. Yeah, that's understandable. I always think, at least at the worst, if you go to college, you at least learn what you don't want to do. You get exposed to a bunch of cool people, and new things. Okay, I need to check those lead-ins and lead-outs. But that's closer. So this is what we're going for. The one that's going to be tough to clean up is the exhaust side here. But this should all go fairly quickly. That's how I've designed this, is so that you can use more basic toolpath to generate each of these profiles. So that's partially what takes so long to program this, is I'm trying to program this with more simple toolpath where it takes less time to do, as opposed to rely on more of the algorithmic stuff, which will do a pretty good job, but it eats up time. So that's not looking too bad. Got to put my counterbores in for the dowel pins and some other stuff. But that's progress. Well, I think I'm going to end it there. Been up since 9 a.m. It's 12:38 a.m. Got something done on this. Happy about that. Thank you all for joining. I don't know when I'll be on next. Maybe tomorrow night, maybe the night after. But you all have a good one. Take care. Have to figure out how to stop streaming. Figured